Okay. Today we're going to be covering polynomials, multiplying polynomials, factoring polynomial by grouping, greatest common factor, factoring trinomials, factoring special case polynomials, and then also an equation. So first of all, for polynomials, a polynomial is an expression consisting of variables and coefficients that involves only the operations of addition, subtraction, multiplication, and non-negative integer exponentiation of variables. An example of a polynomial is 3x plus 25 minus 5. Multiplying polynomials. When multiplying polynomials first, multiply each term in one polynomial by each term in the other polynomial using the distributive law. Second, you add the powers of the same variables using the exponent rule. Third, you simplify the resulting polynomial by adding or subtracting the like terms. Here's an example of multiplying polynomials. You multiply over each term. Factoring polynomials by grouping. Factoring by grouping is a process of grouping the terms together in pairs of two terms so that each pair of terms has a common factor that we can factor out. An example of factoring a polynomial would be this long equation here, but it can be simplified down if you factor it by grouping into this here. Greatest common factor. Okay. The greatest common factor with a set of numbers is the largest factor that all numbers share. So, for example, 12, 20, and 24 have the common factors 2 and 4. The largest of those two is 4, so we could say that the greatest common factor of 12, 20, and 4 would be 4. Okay, factoring trinomials. It is the process of finding factors for a given trinomial expression. The factoring trinomials formulas of perfect square trinomials are a squared plus 2ab plus b squared equals ab, so the a to the second, minus 2ab plus b to the second equals a minus b. And then for our last one here, for the definitions, we have factoring special case polynomials. One characteristic of special products is that the first and last terms of these polynomials are always perfect squares, a squared and b squared. And then for our equation here, our equation is there are two buildings that you want to have in an amusement park, but the size hasn't been determined yet. Although you don't know the specific dimensions, you don't know the relationship between the sides. The first is the rectangular gift shop. You know that the length will be 20x plus 24 feet, and the width will be 36x minus 20 feet. The first question is write the expression that represents the area of the gift shop in terms of x. So what we do is length times width here. So then for our area we have 20x plus 24 and then 36x minus 20. Okay, we get that here. And then it's going to be our final about that. So our final for the area. And then it's going to ask us for the perimeter of the gift shop in terms of x. So then this one we're going to do length plus width for it. So we're going to add up all of those widths here, as you can see. And then what we're going to get is 112x plus 8 for our perimeter, which all of these equations are going to add up to then. And then, okay, for the third part, if the perimeter is going to be 176 feet, what are the dimensions of the building? If the perimeter is going to be 176 feet, we can set the expression for the perimeter to equal 176 and solve for x. So from our last one, we have our perimeter 112x plus 8 equals 176. So first we're going to subtract 8 from both sides, which is going to give us 112 equals 168. Divide both sides of those by 112, which is going to equal us, or give us 1.5. Now that we know the value of x, we can substitute into the expressions for the length and width of the gift shop. So for our length, we get our 20x plus 24 equals 20 times our 1.5 that we got from dividing, plus 24 equals 54 feet for the length. And then for our width, we have 36x minus 20 equals 36 times 1.5 minus 26 equals 28 feet for our width. Therefore, the dimensions of the gift shop are 54 feet by 28 feet. That's it.